Hello everyone, this is Rami Al Quraishi. Today I will be doing a network lab. In this lab you will learn the VLAN concept, spanning tree, ether channel, a trunk concept, and I will be talking about OSI layers as well. So I prepared a Word file that has some information, talk about the OSI layers. Then here we will uh, we will have the lab objective, then the lab topology. So without any further delay, let's start. So before I start talking about the VLAN, the spanning tree, I want to spend some time on the OSI layers, the 7 OSI layers. This is the first thing you need to understand as an IT engineer. Doesn't matter if you are a network or if you are a system engineer, you need to understand these 7 layers. This is very important. You need to understand these layers in order. For example, whenever you ask about this, when you explain this, you need to start like physical, data link, network, transport, session, presentation, application. The way I did memorize this by please do not throw sausage pizza away. It's up to you. Everyone can find her own trick. But this is how I did memorize that. These layers, they provide each layer provides services to the layer on top. For example, the physical layer provides services to the data link layer. Same thing, data link layer provides services for network layer. Same thing for the layer on top. Same thing here until we reach the 7th layer, the last layer, the application layer. This is where you see the exact application in front of you. So to start with, we need to understand these layers. Maybe as a start for you as a network engineer and as introduction level, you do not need to know all these 7 layers. I can tell you that you can survive with knowing the first 4, the physical, the data link, the network, and the transport layer. The other, yes, even for you as a network engineer, you will interact with these, especially if you are applying load balancer, application firewall. However, for introduction, let's stick with the first 4 OSI layers: the physical, the data link, the network, and the transport. These layers, as mentioned earlier, everyone provides services for the layer on top. The physical layer, this is the first layer. This is like we can talk about this, for example, cables or hub. Uh, Data link layer, this is specifically the switch and MAC address, meaning the switch doing the forwarding based on the MAC address. Layer 3, the network layer, this is the IP layer, the routing. Layer 4 is the TCP, UDP. So physical layer, layer 1, is where we have the hub device. Second layer, where we have the switch device. There is a huge difference. Maybe for non-IT guys it doesn't matter, because for non-IT guys they see this as a switch, as a device with many ports. They can plug more than one computer, it serves the purpose. However, this is not true. There is a huge difference between hub and the switch. Of course, hub is an old device, end of life. Most likely you will not see it in deployment, especially right now we are in 2025. The switch, however, is the replacement. There was like a device in the middle called the bridge. It didn't survive that much, so the main jump, it was from hub to bridge, then the switch. The bridge didn't survive, so now we will talk. I will spend some time talking about hub, then the switch. So what is the main difference? What is the hub? As you can see here, I have 5 PCs, computers, users. connected to the hub. Let's assume here one sender want to send some packet to a receiver. Let's say like this is a family gathering. The wife would like to send the husband some pictures, or this is a bank. One employee would like to send another employee some pictures. So what will be happening here? The sender will be sending this whatever data the sender has, and it should be go to the receiver only one computer. However, because of the hub behavior, this will not happen. Whatever the sender is sending, it will be sent to all these guys that are up and connected to the hub. Why is that? Because this is how the hub does the forwarding. It's called flooding, meaning when the hub receives up a data, a packet, let's say from this interface, the hub will send it to all other interfaces except the receiving interface, which makes sense, right? We don't send it to ourselves. So basically, this is the term of flooding. Basically, we receive the packet from one sender, we send it to all other interfaces. Yes, now the packet will reach the destination. However, as an engineers, we should now be thinking out loud. Is this good? The first answer come to my head, yes, because the packet reached the destination. However, thinking deeply, it meant to reach one receiver. Now all these four other computers received it. Now this is not good. If this is as mentioned, the same first example where I said a wife sending a husband some pictures, if there are some strangers here, these strangers will receive this information. If this is a bank, all other users here will be receiving this information. You might be saying, yeah, like all of them are employees. No, I will say this is not true. All of them, they are employees. Why an IT guy or a sales guy would see HR document? For example, the HR document might have all the employee salary. This is a very confidential information. None of the normal employees should see it. So there is a huge concern, a huge security concern here when using the hub. And I want to stop here 1 minute. I will advise everyone watching this video, if you didn't till now, there is a beautiful series called Mr. Robot. I advise and encourage everyone to spend some time on this series. First of all, this series is very beautiful, exciting. Second of all the basically it's about a hacker guy. The guy has like 3 or 4 personalities. Most of them they are hackers, and in hacker life there are 3 types of hacker: the white hat, the gray hat, the red hat, the black hat. Like the white hat, the guy who's always doing good, like normal employee. The black hat, who is like always doing the hack for bad thing, doesn't matter, personal, organization, she, they are doing it for bad stuff. A gray, who is somewhere in the middle. In the morning they are good guys, in the night they are bad guys. So the point is, try to spend some time watching Mr. Robot series. It's very beautiful. Second of all the tools or the hacking tools that was used in that series, they are true, and all the tools that were used there are true as well. So if anyone here connected to the hub, they can open this application. Oh, don't tell me I don't have it here. It's called Wireshark. This is a free tool, open source. You can Google, download it. Right now I do not need to update. For example, here it sees my interfaces. Let's choose which one? here the Ethernet and I start uh, capturing, right now whatever happening here on the network I can see it. If I open not this one, if I open here like ping google.com, here we should see that 888 we see some traffic to the internet. So this is a application to capture data, and if you know to use this application you can encrypt and you can see a lot of stuff happening in your network. The first thing I advise you to do is to practice this tool, download it, try to play with it, because it will show you a lot of stuff that is happening in your network. For example, you think right now your computer will connect to only Google when you open the computer. You are totally wrong. If you do the packet capture, you will see a lot of stuff that doesn't make any sense to you. I encourage you, everyone, to start playing with this packet capture tool. So back to the subject. Anyone connected here with a Wireshark, with a computer that has the Wireshark installed, they can see all your data. This is the hub. In addition, let's say here I have two departments, HR department, IT department. How can I do the separation here between the hub? I cannot. The only way I can do the separation, I need to have two different devices, two physical devices. This is the hub. The last information I would like to share here, since we see like one sender, four receiver, this is called one broadcast domain. Like everything here belongs to this one broadcast domain. This is what you need to know about the hub. Now, smart people, after that, they saw the limitation, then they came with another beautiful device. I mentioned there was a bridge, then now the bridge was changed with a switch. Now the switch, see how smart it is. You have sender, the sender send the data, the switch received this data, then the switch sent it specifically to one destination. It didn't go to other devices. This is the main difference between the switch and the hub. So how does the switch is doing this? First thing, the switch is, so first I said the hub is doing the forwarding based on flooding. The switch is doing the forwarding based on MAC address. So here the switch doesn't do, actually the switch sometimes do flooding, like there are cases when we don't know the destination MAC, so we just discover the destination MAC when we have a broadcast. However, after we learn the destination MAC, we basically do the forwarding based on destination MAC, meaning here the switch, if you are sending here, the sender is A, the receiver is B, it will not go to C or D, it will go from A to B. So the switch is smarter. Here we have two main benefits. The first thing here is, if I have the same tool I was showing you earlier, Wireshark, and I am here, I will not be able to intercept the traffic between A and B, because the switch is not sending me this. The switch is not sending this as a flooding. The switch is sending this based on destination MAC address, and we know it will be here. And other benefit of the switch supports something called VLAN, virtual LAN, meaning I can do a separation. I can create, for example, two VLANs. I can call this like VLAN 1 IT VLAN, and name the second one HR VLAN, and put these two computer in VLAN 10 IT, these two computer in HR, and they will not be able to communicate with each other, because now they are in different broadcast domains, meaning I can do the separation without buying physical devices similarly to what I said in the hub. So in the hub, two limitations. The first one is we do the forwarding based on the flooding. Second thing, we every interface belong to one broadcast domain. In the switch, we do the forwarding based on the MAC address, and we can do more than one broadcast domain. By this I mean we can configure more than one VLAN. So with that being said, right now I will start with the lab. The lab, basically I will be configuring some VLAN and assign the IP addresses to those VLAN. Then also I will be playing with the spanning tree, and I will also playing with the ether channel. It will not make sense right now to talk about the spanning tree and ether channel unless I configure everything, put everything to work. Then I will show you what limitations I am facing here on the switches and why we need the spanning tree. Then once we see the spanning tree, then I will talk about why we need the ether channel. So this will be my topology. This my EVE-NG. The first thing I will be doing here, I will start all devices. So what I have here, I have 4 switches, 4 computers. And here I have around 5 VLANs, VLAN 10 HR, VLAN 20 IT, VLAN, actually here I have duplicated, and I have the 30 the voice, and I have the VLAN 40 the management. And of course I will be creating another additional 100 VLANs just to play with the spanning tree. So I show you like how to play with the spanning tree to influence the election, what is the root bridge, everything else. So right now let's come to our topology. The first thing here, I need to create the VLANs. I need to create the VLANs in switch 3 and 4 and assign these ports to these VLANs. Also after that I will be creating the trunks. So the first thing here, let's start from switch 1, switch 2, switch 3, switch 4. Before I create the VLANs, I will be doing some minimum configuration, and I will be spending some time to talk about the mode of operation in Cisco switch, Cisco box, Cisco device. So the first thing here, what you can see, this is called PATI. This is a terminal. What is a terminal? This is how we, as an engineers, we interact with the network device, we manage, we configure. So what is a terminal? A terminal is your way to configure Cisco switch, Cisco router, Cisco firewall. A terminal there are many terminals. Right now I'm using PATI. Also I have Secure CRT, but Secure CRT is a paid one. You pay money for it. PATI is a free one. So of course, if I were you, I will play with the free one. Also in the Windows PowerShell, I believe right now in the new versions like Windows 11, you can enable SSH, so it's enabled. So the first thing here, this is meaning I am logged into the switch via console when I click here. What does a console mean? Whenever you unbox Cisco device for the first time, you need to connect to the device through console cable. However, let's say I will take Canada as example because I am based in Canada. Let's say like you live in Toronto and you work in a huge company, a big company that has many branches, and there is another branch in British Columbia, Vancouver, where it's like around 4,000 kilometers away. So you work on a project, you stage a Cisco switch, then you ship it to Vancouver. Then later the Cisco switch has some problems. It doesn't make sense. Your manager asks you to go troubleshoot. They will buy you tickets in the airplane. That's why there is another way to access the device, which is remotely. So let me recap. There are 2 ways to access the device, Cisco device. Either through console, physically, you go there with a cable from your laptop to the switch, or the other way is remotely. Remotely, there are 2 ways. Either telnet or SSH. Telnet is the way that you should only use that in a lab. If you are doing cybersecurity assessment and you see this, you should smile, you should be very happy because this is a huge vulnerability uh, found, like something very precious you already found. So Telnet should be only used in a lab environment because everything is being sent in a plain text. A plain text meaning there is no encryption. Anyone sitting in the middle here can have this Wireshark tool open, they can see the traffic. SSH on the other hand, where should you use that? Basically here we generate a crypto RSA algorithm to encrypt our traffic, meaning of course nowadays with all these AI models, even SSH can be intercepted. However, for now, this is secure. So the first thing you know about the switch once you log in, you will land in the user mode. How do you know that? By the greater sign. The user mode is like the read-only mode. You cannot do anything from here, and the first step here would be to type enable to go from the user mode to the enable mode. The enable mode here is where you can play more with the device. Here is the most when you do your troubleshooting part. Here where you do show the commands. Even from here you can reload the device, or if it's a modular device, you can reload like a part from it. For example, you land here on a device, the first thing you do, show version to check like what's happening. Of course, I'm using a virtual box, but I'll tell you here two important information. Where is the image, which image I'm running, and here what is the uptime. For example, you are working in one company and like you are a consulting engineer. Before you there is a one team, they call this NOC, where they are 24/7, they are available for the client. And this is of course a big company, like for example if you are working in Bill and Roger, where you have client everywhere, you need to have 24 support for the clients, right? So like you have an issue, then they woke you in the night and you check that you see the uptime is 5 minutes. Right away it should ring a bell in your head. There was a power issue on the site. Okay, so at least this is a very useful place where you land and where you should check. Then from here you type conft or you type configure terminal. Let me tell you here a bit of advice. Like for me, talking personally, I'm not English native, meaning English is not my primary language. So if you were like me when you come to this path, maybe you were not English, maybe your spelling were not good, your pronunciation was not good, but most important, if you were writing something, your spelling not good, I will give you two advices here. Your best two friends in networking in the CLI are the tab in the keyboard, the tab, and the question mark. For example, instead of me typing configure terminal, I type config T terminal. I press the tab. The tab auto-complete that for me. It helps a lot. Believe me, if you spend all your day typing, you need to find shortcuts. Then the question mark. For example, let's do like that. IP route. You see the tab doesn't complete it, but I know from experience there is a keyword. I press the question mark. You see, that's why the switch didn't complete it. Oh my god. Show IP route question mark. IP route question mark. So the switch didn't complete it because after what I typed, there are two options, either E or ING routing. And what I have found also from experience, you can either call this routing, the same as I am saying right now, routing, or you can call it routing. Both are correct, but this depends on wherever you came from. Like I found that the UK The UK accent, they pronounce that as routing. The US guys pronounce that as routing. So for me, I am going with the routing. This is how I am used to it. So this is the question mark and the tab. The first thing here you should do after you configure, after you access the switch, you come, you give your switch a beautiful host name so you know what to troubleshoot. Imagine, and this happens a lot, believe me, after 13 years in this field, I still see people put this is stuff in the default name, and once I go to troubleshoot the thing that should be I spend 5 minutes, I spend 2 or 3 hours because I don't know where device I am in, and I need to start digging, send some technicians to the site to do some tracing for the cables. And believe me, it is very hard nowadays to deal with technician. Anyway, so the first thing here you do on the switch, you disable, you give your switch a beautiful host name. Then the second thing, you go to interface, you go to line console 0, logging. Of course, you need to type properly, logging synchronize. Then you do the same thing here for line VTY 0 space 4, logging synchronize. If anyone here noticed, here I have line console 0, but I have line VTY 0 till 4. What does that tell you? That should tell you I only have one console port, meaning one engineer should be connected to the switch through a cable, because on the switch there is only one console port. You can only connect one console cable. However, this virtual switch support 5 sessions starting from 0 till 4, meaning 5 sessions. So 5 remote engineers can connect to the switch to do whatever they want to do. This is the main reason why you see here line console 0, line VTY. What I did right now, logging synchronize. For example, if I am typing something like here, interface VLAN 5, and some log appear, the log will not be bothering me, and it will be like this, so I don't know where I am. It will be showing on the second line, so everything will be beautiful. Second thing I want to disable is no IP domain lookup. What does this do? If, for example, here I type something wrong, it will spend around 1 minute trying to resolve this to DNS name. So that's why these are two important things to disable whenever you log into the switch. Of course, if you are working in a good company, in a organized company, the other important thing you need to do is disable VLAN 1, because this is the default VLAN. However, right now so I talked about the VLANs, how to assign the VLANs, but right now let's spend some time talking about like what are the VLANs. So the first beautiful command here we have show VLAN brief. BR stand for brief. Show VLAN BR tab brief. As you can see, I have the VLAN 1 by default, these also other 4 VLANs. None of these can be deleted, but you can disable the first VLAN, and this is my first advice to you, to disable the first VLAN, because like right now the hackers, the first thing they do, they attack the default stuff, like you leave your default password in the default state. Of course, everyone is guessing that. So this is how you check the VLANs, show VLAN brief. This is how we see our switch. Like this switch can support up to 1005 VLANs. In a VLAN, in a VLAN in a switch, we can have a layer 2 VLAN, a layer 3 VLAN. A layer 2 VLAN, a VLAN only concerned with a MAC address. A layer 3 VLAN, this is what we call on the other hand SVI. This is where we configure the IP address. So basically here How many VLANs I said I have? Basically, I said I have on each switch, I have 4 VLANs. VLAN 10 HR, VLAN 20, VLAN 30, VLAN 40. Actually, I can just copy paste. No, let me for the first time. So VLAN, the first time I will type it, then later I will be copying those. So VLAN 10 HR, either you can do like this, VLAN 20 name IT, or you can exit, then you can do VLAN. Of course, for me, I will do it while I am there. Here I have the voice VLAN, and then I have VLAN 40, which is for the management. Then I have my VLAN 100 till 200. So right now, let's do the same on switch 2. What did I do? What did I say? I cannot speak and type in the same time. So actually, what did I say? This is the hub behavior. Also, I forget to mention that one of the issues, one of the limitation in the hub, that the hub work on something called half duplex, meaning if this is all, if all these are hubs, if hub 3 would like to send something to hub 1, it's okay. But if hub 2 and hub 3 are sending this in the same time to hub 1, we will have collisions, meaning we will have some drops in the network. This is bad. This is happening only when we have a hub or we have all devices in our network. So this is one of the limitations. Sorry, I forget to mention earlier in the hub. I believe next time when I should be doing the videos, I need to prepare maybe in the other screen some tips. Anyway, speaking out loud. So we rename our switch 2. Then I will not do the synchronization. I wanted to show the students, everyone here, how to do it. So right now paste, boom, I have my configuration. Right now let's do switch 3, enable, configure terminal, hostname switch 3. I created my VLANs. Right now I'm doing switch 4, and of course I didn't follow my own advice. Hostname switch 4. If you are wondering how to save the configuration, we do it like this. So in Cisco there are 2 types of config. They call it the startup config, and they call this the running config. The startup config, this is where the device, like when, let's say right now the device had some power issue. When the device will boot up, the first thing the device will boot up from the startup config. Then when you start to work here on the config, like when I created right now the VLANs, this will become the running config. The running config, if you didn't save and you had a power issue, you will lose your config. So how do I do that? WR, what I did right now, stand for copy, running config, startup config. Actually, so this is how we save the config, copy running config, startup config. So right now I already created the VLANs on all my 4 switches. Right now let's come and assign these PCs. So especially these are in switch 4 and switch 3. So in switch 4 it says Ethernet 0/1, which is here for PCA, this should be in the HR VLAN. So interface Ethernet 1/0. Let's put description PCA switch port mode access, switch port access VLAN 10. Then I do interface Ethernet 1/1. This is for PCB, which it will be in VLAN 20. I believe VLAN 20 was IT. Description PCB switch port mode access, switch port access VLAN 20. We save our beautiful config. Now I come to switch 4. Let's first verify show VLAN brief. I see that Ethernet 1.1. Okay. So right now let's go to switch 3. Okay. I need first to calm down and start typing properly. Interface Ethernet 1/0. This is the thing with me typing on the keyboard on the CLI. I always type fast. So we assign this interface to PCC, description PCC, and here we said PCC in VLAN 10. Switch port access, switch port mode access, switch port access VLAN 10. Interface Ethernet 1/1. Description PCD. We said this is VLAN 40, the management. Switch port mode access, switch port access VLAN 40. I save. So right now on the switch I do show VLAN brief. I see only the Ethernet 1/1 assigned to VLAN 40 and only 1/0 to the HR, and this is what I actually want. Now what I will be doing, so right now what I talked about is the access, which are these ports. So right now these ports for the switch, they are layer 2 ports, meaning they can deal with the MAC address. You cannot assign IP address to these ports. These layer 2 ports, they either can be access or a trunk. What does that mean? Access, I already explained that. For example, this part Ethernet this port Ethernet /0 1/0 is a part of VLAN 10. When you do it access, it can only belong to one data VLAN. Also, here this interface is part of VLAN 20. However, these two interfaces between the switch 1, switch 4, switch 1, switch 2, switch 2, switch 3, these shouldn't be configured as access port. Why is that? Let me tell you a use case. Here, for example, PCA and PCC, for them to communicate, one of these interfaces should be a part of VLAN 10. If I come right now, open PCA, so I said for PCA the IP address should be 192.168 10.1. I will open continuous ping to 192, 168.10.2, which is PC2. Obviously there is no ping because I didn't configure it yet, but let's come to PCC. So this computer will be ten. So even though I configure the IP, I still do not have ping from here, and it makes sense to me because now these two interfaces, they are part of the default VLAN, which is VLAN 1. Show VLAN brief, we see that Ethernet 0/00/1 part of VLAN 1. However, if I will bring one of those like Ethernet 0/0, let's take for example switch port access VLAN. It was which VLAN 10. Then I come here, do the same thing on switch 4. Now I should see my beautiful pings start to work. Give it time for the spanning tree. I will explain about the spanning tree in a moment. But for VLAN 10, we see that now it's learning. Once this will be forwarding, then I will have my ping. So now the ping started to work because this interface is part of VLAN 10. This is fine and working okay. If I want to do another thing for VLAN 20, meaning I want to put this in VLAN 20. If I have here 10 PCs, this will work fine. But let me show you one thing. Show IP interface. So this command stands for show IP interface brief. However, how I type it, show IP interface brief. If you have here 200 VLANs, meaning you need to have 200 interfaces. I do not have 200 interfaces. So the solution for this, to configure these two ports not as an access, we configure these two ports as a trunk ports. What is a trunk port? A trunk is a layer 2 port that can carry all the VLANs. What does that mean? Mean here, instead of here having 200 interfaces to configure the 200 VLANs I have, or the 10 VLANs, 10 interfaces, I will only have 1 or 2 interfaces. Like here, only one interface between switch 3 switch 4 will work, but the main reason for I added those because I want to show you EtherChannel like after I talk about the spanning tree. So this is the main reason why I have 2 interfaces, but only, even if I only have one, it will work. So right now we know what is a VLAN. A VLAN is a virtual LAN. It's my own. The VLAN has its own broadcast domain, meaning here PCA, PCC, they are in VLAN 10. Only these PCs will be able to communicate. PCB in VLAN 20, PCD in VLAN 40. they will not be able to communicate. If you get such a question in the interview, why is that? Because each VLAN has its own broadcast domain. Is this doable? Yes. How we do that? We need to have a layer 3 device, a funny terminology here is called, it's called router on a stick. This is how we can achieve the network reachability between the layer 2 VLAN. By default, PCs, computers in VLAN 10 will not be able to communicate with any other VLANs. This is the default behavior for the switch, and this is a very good security mechanism. So right now, before I proceed, I believe my next topic will be to configure the trunk between all the switches, but I will do the first. So I will, because I assigned the interface Ethernet 0/0 to VLAN 10, I need to remove that. There are two ways to do it. Either I come here inside the interface Ethernet 0/0 and I do no switch port access VLAN 10, or I prefer this way. Of course, this is not a production device. I can do whatever I want. So I do default 0 slash y default interface 0 slash. By the way, empathy, how do you copy? Just by highlighting. How do you paste? By typing right click. So right now I want to paste this here. I do it here and I have my copy paste. So right now we know what is a trunk, what is a VLAN. Right now let's come here and assign my interfaces to my VLAN. So for example, I am in switch 4. I have all these interfaces from 0/0, 0/1, 0/2, 0/3. So what I will do, interface range Ethernet 0/0 till 3, switch port mode trunk. Of course, the switch now will complain, and I will explain this right now. Switch port trunk, switch port trunk. So we have two kind of trunk encapsulation, two protocols. Either .1q, which is we should be using, or ISL. ISL is dead. No one should be using this. This is end of life. So what I will be using here, switch port trunk encapsulation .1q. Then I will do switch port mode trunk. I will do the same thing on all my switches. Of course, you will see the interfaces here flapping, but let's do it now on switch 1. Switch port mode trunk. Now the switch will complain. Switch port trunk encapsulation .1q, and now I do switch port mode trunk. I save my config. I come to switch 2. Switch port interface range Ethernet 0/03, switch port trunk encapsulation .1q, switch port mode trunk. And I believe I have the last one here, interface range Ethernet 0/03, switch port trunk encapsulation .1q. So if you see here, actually let me verify. So for the VLAN, do you see right now couple interfaces here disappeared? Like, where is 000102? Because this command show you only the access port. How do you check the trunk port? Show interface trunk. As you can see, we can see that we have these 4 interfaces and they are passing all these VLANs. So what I wanted to talk about, like, you land here, this is not good. Like, anyone right now can click here, can access the device. Anyone can go to from the read-only mode, the user mode, to the enable mode. Anyone can right now reload the device. So this is not a good security concern. So what do we do here? we take couple steps. First thing here, we do user name Rami, password Rami, user name Cisco, secret Cisco. Then I do enable. So let's see what is this username Rami. I exit here, exit, I type here. Actually I need to apply that. So first I apply this to the line console 0. I do login local. I am forcing the switch to use the login credential I just used. So right now, if I come on the switch, I click here. Now the switch is asking for username and a password. This is how you should do it. Not anyone, you shouldn't let anyone just come and configure that, even if they are employees from your own company. So my name was Rami, password was Rami. I come here, type enable, conf t. Also, additional step I will be doing here. I just typed enable, I came here. I need to do enable password Rami. Now I exit, I type exit, I come here. Now the switch is asking for a username, a password. When I type here enable, it also asks for a password. This is how you should secure your beautiful switch. Right now, let's see if anyone paid attention here. I used two commands. I used, if I can find them, I used username Rami password and I used username Cisco secret. What is the difference between this? If I do here show run, I will see that when I use the command password, I can see Rami in a plain text. This is not a good practice. However, when I use secret, I see that now the password is encrypted. So the best way is always to use, in addition, I should also see the enable password, which is here, Rami. So do you see here, these are in plain text. So the best practice is always to use secret, or there is also this command, service password encryption. Now if I do show run, you see that the password right now somehow is encrypted. The password is, of course, this is not like a big deal. Like right now, if you type any, for example, password 7 decryption, and I bring my, where was it? It was which switch? So I bring this, I put it here, submit. So right now you see that this is not encrypted. However, somehow it's a mechanism. So always it's better to use the secret when you configure your password locally on the switch. So we have assigned the interfaces VLANs. These PCs I have assigned here the trunk interfaces, and we have right now, let's test the PCs again. Actually right now this should be pinging, because right now all the interfaces are configured as a trunk. If I do the ping from the other side, meaning from, I do not need that, I do not need this drive. If I right now do the ping from here to this was .2. If I do the ping to 192.168.10.1, I should have my beautiful ping here as well. So the connectivity that I want to achieve right now is working, but let me see if I, yes. So right now, let's do a couple verification. Right now, let's talk about the spanning tree. Before I talk about the spanning tree, why the spanning tree exists in the first place. So the spanning tree, basically it's a protocol that block redundant link. What does redundant mean? Active. So I have two links, active and a backup, active and a passive. So the spanning tree will be blocking one here, one here, one here, one here. This is a waste of resources. Why does the spanning tree do that? This is a loop prevention mechanism or a broadcast storm prevention mechanism. In layer 2 and until this day I see this a lot. I see experienced network device network engineers, they do not pay attention to the spanning tree. For example, they leave all the switches in the default priority. They do not promote any like two or a switch as a root bridge switch, no BBDU guard. Anyway, so why we have the spanning tree protocol running in like in layer 2 in the layer 2, and actually this is running by default like out of the box when you like right now if I come here to switch 1 Rami enable Rami show spanning tree. I didn't configure this but it's already here. So the purpose for this to prevent loop. What is a loop? If a loop is if PCA would like to send something to PCC, it should come from PCA to switch 4, switch 3, then come here. However, it might be coming to switch 4, switch 1, switch 2, switch 3, then switch 4, switch 1, then it keeps circling like this forever. What will happen if this will happen? The first thing, let me show you here one thing on switch 1. If I do show MAC address, I see that I have these MAC address tables and I can learn these two MAC addresses. So this is how does the switch do the forwarding. So the switch here doing the forwarding based on the MAC address. The switch is showing me this output based on the switch actually is using resources, CPU and memory. So the switch put this here for 300 seconds. This is called the idle MAC timeout. If for 300 seconds this ping will stop, which I am putting here, then this MAC address will, couple of MAC addresses here will disappear. Why the switch is doing this? Because the switch wants to save its CPU and memory. If we have a loop in our network and the packet keep here circling forever, basically the switch will be wasting memory, resources, memory and CPU. In addition to that, it will also consume the bandwidth here on these two interfaces. Eventually, the switch will run out of memory and run out of CPU, and the only recovering way, even for you, if you go connect to the console, the switch will not have enough memory to ask you for username and password, and the only recovery state from this one will be to power off, powered on again the switch, meaning restart the switch. Like you cannot do it like this. Most likely these switches, they do not even have like a start off button, so most likely you will need to remove the power cable, put it back. So this is why we have the spanning tree, to prevent loops. Let me show you here on switch 1. For example, like show spanning tree VLAN 10. Switch 1 actually is forwarding. Switch 1 was a bad example to see. Show spanning tree VLAN 10. We see that on switch 2 we have a blocking port Ethernet 0/1. If I come to switch 3, I have I have many blocking ports in VLAN 10. 1, 2, 3. If I come to switch 4, I have also a blocking interface. So as you can see, this is waste of resources. We are wasting that resources. So that's why we have another protocol after that called the EtherChannel. But before I move there, let's spend some time on the spanning tree. How does the spanning tree work? So you see here I have 4 switches. The first thing, these switches need to do some election to elect a root bridge switch, meaning one switch here will be promoted as a leader, as a boss. Everything will be flowing through that switch. And this is one of the hacking methods that you can plug here a Raspberry Pi. If you don't know your Raspberry Pi, like it's a small computer, you can call it, you can install on it Ubuntu. You can Google, ChatGPT that. However, with some tools like Cable and Hen, Cable actually, you can make this Raspberry Pi as the root bridge switch. If no one here from the network team has any clue, if they didn't put any PBDU guard, root guard, the Raspberry Pi here will be the gateway for the spanning, and every traffic will be flowing through the Raspberry Pi. If you have this Wireshark, you can basically decode all the traffic for the company. So, how does the spanning tree election happening? These 4 switches, they need to elect a root bridge switch. The root bridge switch election is happening based on 2 things. Every switch has something called the bridge ID. Let's take switch 3 for example. This is what called the bridge ID. In the bridge ID there are 2 information, priority and the MAC address. So whenever here we do spanning tree election, the switch that win the election will have either the lowest priority or the lowest MAC address. So this will be checked in order. The first thing we check the priority, the second thing we check the MAC address. The priority by default for all switches will come with 32,778, meaning if we are only depending on the priority, we will not promote or we will not elect a root bridge switch because all of them in the same default priority. That's why we have another tiebreaker, which is the MAC address. Now the switch with the lowest MAC address will win the election, and I already saw that. If I show you here in VLAN 10 switch 1, it is saying that this is the root bridge, meaning here in this topology switch 1 won the election. So from the spanning tree, show spanning tree VLAN 10, we can see that we can have here 2 values. The bridge ID, this represent the information for switch 3 itself. The root ID, this information represent how can we reach the boss, the leader. It's telling you for VLAN 10 perspective, we can reach the boss by from this interface 0 Ethernet 0/2, which is this one. So if I come here, when we come to switch 2, the same thing. This is my information, switch 2 information. This is how to reach the root bridge, the boss. It's telling you to reach it, we go from 0/0, which will be switch 1. Let's compare. Now if I come to switch 1, show spanning tree VLAN 10, see the difference between switch 1 and switch 2. In switch 2, it's telling you how to reach the root bridge. In switch 1, it's telling you, I am the root. This is the bridge. This is the other information. So this is how you verify. Now that we have verified, we have something on the root bridge switch with on interface. This switch, I said, everything will be coming to here, meaning all these ports need to be designated. Designated meaning forwarding. This is what we can see here. We can see that switch 1, all its ports are in designated mode, forwarding, 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 forwarding. Now let's take switch 2. Switch 2, it has something called root port, alternative, designated, designated. Designated mean also always forwarding. What is the root port? The root port here on the switch 2, Ethernet 00, this is the shortest path to reach the boss. The shortest path, to reach the root bridge switch. So we use this port as the shortest path. Ethernet 0/1 is alternative, now is blocking. This is once the Ethernet 0/0 is down, this will be right away the active. So as you can see right now, this is also a waste of resources. Now let's take switch 3. It's telling you this is my information. To reach the root, I use Ethernet 0/2. So now we have learned a couple terminologies. Let me recap in the spanning tree. So why the spanning tree protocol, the technology protocol exists to prevent loops at layer 2. How does this work? The spanning tree need to elect a root bridge switch. The root bridge switch basically, how does the root bridge switch election is happening? This is happening by the switches exchanging the hello messages every 2 seconds. These hello messages include two important information, the priority and the MAC address. By default, all the priorities are the same, which they are 32,778. So this is the first value that will be checked. Everything here is in the same, so we need to have another tie breaker. We need to break the loop, so we will be looking at the MAC address. Switch 1 MAC address will be the lowest, that's why the switch 1 win the election. We said in switch 1 all the ports are designated, meaning switch 1 ports are always forwarding. And by the way, switch 1 will be sending something called BPDU, including telling all the other switches that the switch 1 is the root bridge for the spanning tree topology. Now, switch 2, I said we have a root port. What is a root port? Is the shortest path that we use to reach the root bridge switch. All other ports are designated. The blocking is alternative to the root port. By the way, here, did you see what I typed some typo? Right now, the switch is hung. This is why if you go back in the video, this is why I disabled on the first switch. I did no IP domain lookup, because if I will do this mistake, I will not be right now waiting here to hang. Of course, there is another way to break this. On the keyboard, you need to type Control Shift X couple times 6. Keep that. I believe I will be hitting yes. So this is what you need to know. Of course, there is something called root port, port fast. There is the BPDU guard. There is the filters, but I will not talk about this. The main purpose here, just to this is introduction. At least you know how the spanning tree work. For example, here right now in the lab, I did create VLAN 100 to 200. So what I want to do right now, I want to do some kind of load balancing. I want the switch 1 to be the primary root bridge for the spanning tree from VLAN 100 till 150, and I want to be the secondary from 150 till 200. So I want to achieve some kind of redundancy. What does that mean? If I have here as mentioned VLAN from 100 to VLAN 200, right? I don't want all these to pass through one switch. I want to do some kind of load balancing. So I want switch 1 to be the primary for VLAN 100 till 149, and I want switch 2 to be the primary from 150 till 200, not to make everything passing through switch 1. Then what I will do here, I will do switch 1 secondary from 150 till 200. In case of switch 2 failed, primary. primary. So that's what I have here. Switch 1 is the primary for VLAN 100 till 150. Then switch 2 is the secondary for this. Actually here, sorry, it should be and switch 2 is the switch 1 is the primary for this range 100 149, and if in case of a switch 1 fails, switch 2 will be the secondary for those VLANs. And I have a switch 2 is the primary for 150 till 200, and in case of a switch 2 fails, switch 1 will be the primary for those. Only in case of a switch 2 fails, the same thing here, only if a switch 1 fails. How do I do that on switch 1? There are more than one way to do it, but I will be doing with the easiest way. So I come here, I do spanning tree, VLAN 100, 149, root primary. Then I do from 150 till 200, root secondary. I save my config. Then I come to switch 2. We said spanning tree, VLANs 150 200, root primary. Then we said in case of a switch 1 fails, we want this to be the primary only if switch 1 fails. If I come here, do show spanning tree VLAN 100, I see that this is the root bridge. If I do here show spanning tree VLAN 150, this is the root bridge. If I do show VLAN 150, this is not the root bridge. As you can see, I use 0 0 to reach the root bridge, which is this one. So this is the spanning tree. This is how we assign couple interfaces. We play with the priority. So right now I will be configuring EtherChannel. What is EtherChannel in the first place? Why we need the EtherChannel? So the EtherChannel is to overcome the limitation for the spanning tree. So right now, why the spanning tree is in blocking one link here, one link here, one link here, one link here? Because the spanning tree here sees 2 links and it's afraid that it will do a loop. So the solution is to fool the switch and bundle these 2 interfaces under one interface. We call that EtherChannel all port channel. So from a spanning tree perspective, a spanning tree will be seeing this as only one interface. If this is a gigabyte interface, then the spanning tree total will be 2 gigabyte interface, because we will have total of this bandwidth. We will double the bandwidth. Here these are Ethernet. Let me show you this. So let me recap before I proceed. First, I cover the 7 OSI layers. Layer 1 is the first layer, which I said the hub, do the forwarding based on the flooding. Second layer is the switch, do the forwarding based on the MAC address. Third layer is the router, do the forwarding based on the IP address. Fourth layer is the TCP UDP. I will show you, I will talk about it a little bit. Then layer 5, 6, 7, let's do not worry about that for now. Then I talked about what is a VLAN. It's a separate broadcast domain. On the switch, how many VLANs you can create, this means like 10 VLANs you created, it means that you have 10 broadcast domains. On the hub, you always only have one broadcast domain. Right now on the switch, if we have redundant link, we will be ending up with something called loop or broadcast domain. How do we avoid that? By configuring spanning tree. So the spanning tree avoid loops. How does the spanning tree works? The spanning tree elect a root bridge switch. That root bridge, by exchanging and looking at the BPDU, the hello messages between the switches every 2 seconds. How does this election happening? By looking and comparing the two numbers that included in the bridge ID. What are these two values? They are the priority and the MAC address. The priority by default is always the same. The MAC address always different. So basically here the lowest the MAC, then we will have the election. Now, to overcome this limitation, meaning the spanning tree blocking some links, we need to configure the Ether channel. In the Ether channel, we have two protocols, either the PAC-P, which is Cisco, or LACP, which is the open standard, can work on Cisco and all other vendors. One of the most important thing you need to understand, if you configure switch 1 with LACP and configure switch 2 with PAC-P, this will not work. Very similarly, if one guy is speaking Arabic, one guy is speaking Chinese, they will not be able to communicate. However, if both guys will be speaking in English, they will be able to communicate. The same thing here for the switch. This is different protocols, meaning if you want to make this modular open standard, you should be working with LACP. Now let's configure that on switch 1. So I have Ethernet 0/1 between switch 1 and switch 2. So what I will do, I will do interface range Ethernet 0/1, and I will do channel group 1 mode. So PAC-P, auto and desirable. LACP, active and passive. What does this mean? PAC-P, if we configured one side as auto, one side as desirable, so one of them will be sending the negotiated packet, one of them will be waiting for it. The same thing with active and passive, meaning if one side is active, other side is passive, the active will send the negotiation packet. If both sides are active, this is fine. Both are sending, they will be ending up negotiating. However, if you set both sides as passive, your Ether channel will never came up because both of them are waiting passively to receive something. No one will start the negotiation. So this is, or it's better always to configure it with the mode on. So right now I will be configuring this as a mode LACP. I will be configuring all site with active. So I will be channel group 1 mode active. This is for between switch 1 and switch 2. Now I will configure between switch 1 and switch 3. So this will be channel group 2. Now let's come to switch 2. Channel group 1 mode active, and here we said from 2 to 3 channel mode 2 active. Now let's actually, let me complete 3, 4, then I will do the verification and we troubleshoot if something goes down. Interface range Ethernet 0/0 till 1, channel group 1 mode active, then here 3, 2. Now I come to my last 4 switch, enable conf interface range Ethernet 0/0-1, channel group 1 mode active, then here 2 and 3. So right now let's check on switch 1, for example. I do show ether channel summary to see. I have 1 and 2, so let's read. So port channel 1 says cap S cap U. What does those mean? Cap S layer 2, correct. U in use. And I see in switch 1, in port channel 1, I have two members, Ethernet 0001, and in Ethernet, in switch 1 here, also in port channel 2, I had two members. All he says P, meaning bundled. This is very beautiful. This is what I want to see. Now, if we go back to switch 3, previously here I was showing you for VLAN 10, see how many blocking ports. Now let's see, show spanning tree, VLAN 10, none blocking at all, because right now we only see as one port channel. This is the beauty for the port channel. In addition to that, here I have something new. This is port channel. So in port channel 1, but why I don't have the port channel 2 here on switch 3? Oh, of course. So what I will be doing, interface range Ethernet 0/2 till 3. This will be 2, and I believe I did the same mistake here on switch 4. No, actually I'm wrong. Nearly. Beautiful. If I come here, so why my ping right now doesn't work? So my ping between, actually now it started to work. It's the spanning tree. Anyway, because the port channel is up, why is that? So when there is some flap and the spanning tree takeover, there will be a wait of 45 seconds. Why is that? The spanning tree will be doing 3 operations. The first 50 seconds doing something called learning. Anything will be dropped. Second operation will be called listening. It will also drop for 15 seconds. Then the last one is forwarding. So in this time, the spanning tree will be dropping the packet. To overcome that, we need to configure something called port fast, either access port or trunk port. This is not what I want to spend some time today. The video already being long so far. So right now we cover the spanning tree, the ether channel, the VLANs. Right now let me show you one thing, how I can do some filters between switch 3 and switch 4. So right now we just saw that the ping here is working. Let me show you one thing on switch 3. If I do here show interface trunk, we see that we have port channel 1 and 2. They are passing all, like for example here, port channel 2 between switch 2 switch 3 is passing VLAN 10. What I will do here, interface port channel 2, I will do here switch port trunk allowed VLAN remove 10. Right now I should see my ping stop working. So basically what I did right now, I did some filters here and I did filter out. Like, this is very important if you will be troubleshooting right now. Everything you see here is up. If I come here to switch 4, I see everything is up. Show IP interface brief. None of my interface is down. Show spanning tree VLAN 10. Everything is forwarding. I have no issue. Show interface trunk. I see that in this switch everything is passing. However, if I come to switch 3, show interface trunk, I don't see on the ether channel part 2 is passing. Actually, what will happen right now, after 45 seconds, this will also start to work, because now the spanning tree will be switching this. As we can see, this has been added. So if we waited for some time, this will be back again. If I want to filter that for sure, I will come here, interface port channel 2, switch port, trunk, allowed, VLAN, remove 10. Now for sure I know this will never work, because basically I pruned the VLAN, I removed the VLAN from all the interfaces on the port channel. Now it's still work. Oh, but I don't have the command. Okay. Oh, maybe I was doing it on switch 4. So for now, for sure, I don't have VLAN 10 is happening. So right now, this is not going to forward. So with this, I believe I completed the lab. I did the LICP. I did apply the filter. Actually, sorry, I forget to configure the remote connection. So now let's configure maybe switch 2 for telnet. So forget about switch 2. Let's configure switch 4. So for example, here for switch 4, I can come here, interface VLAN 40, IP address. This is what called SVI 40.4. Show IP interface brief. I see my VLAN 40. This computer, if it's assigned on the correct VLAN, it should be pinging that switch. It should be here 190. I said for the PCD 40.5. I'm trying to ping the switch. Okay, which works. So right now let's try to, this is PuTTY, the terminal I was talking about. Let's try to access the switch with SSH. It should not work because I didn't configure that. The same thing for telnet. Now let's configure the switch 4. The first thing I do, username Rami, a privilege, let's not do privilege, secret Rami, and here I do line VTY, which concern the telnet. I do something here, transport input all. Basically here I more than one option, but I am allowing now everything. Or I can do like this, telnet SSH. Then I will do here login local, and I will also create the enable secret, which is run. Now let's test the same thing. So 192, 192, 168, 40.4 telnet, and I have my beautiful prompt, Rami, 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 Rami. I am on the switch, Rami again. I type, I'll show IP into brief. Actually, right now, if I come here and I type who, I see that one is in the console, one is on the NVTY. See this beautiful trick. I will send a message. Hello, baby. And you type Control Z. I should see this message here. Hello, baby. So, one beautiful trick you can learn in Cisco. So, this is how we configure a telnet on switch 4, but right now if I come here, even I allowed here the SSH, it will not work. SSH config, I said it's encrypted. So if I do here SSH, basically it will not work because I am missing one key element. I need to generate the crypto key algorithm, crypto key generate RSA modulus 2000. This is how strong it is. The larger the number you have, the more complex it will be. Of course it asks to IP domain name. Let's call this butnetworks.com. Then I do my command. Let's see, now it's configuring. Right now let's repeat the process with the PuTTY. 40.4, and I have what happened? (192, 168, 40.4). Okay. So right now Rami, and I am boom with the who, or you can do show users. So this is how we create a VLAN, a layer 2 VLAN. You create a layer 2 VLAN by just typing like this, VLAN 500. This is a layer 2 VLAN. How you create a layer 3 VLAN? Show interface VLAN 500, IP address. Oh my god. Also, I mentioned one thing, like I mentioned here, show IP interface brief. I mentioned like these are layer 2 ports. For example, if I come here, interface Ethernet 2/0. If I put here IP address, there is even the command is not recognized. However, if I do no switch port, then I do here IP address. Right now I can configure IP address. So this is how also I showed you how to convert the link from layer 1. From layer 1 to layer 3. If you want to reverse that back, you do interface Ethernet 2/0 switch port. Right now show IP into brief. You see that it's gone. I hope this video was informative for you and you learned some beautiful information. Have a nice day, everyone.